for interaction, we will have the poster session after the lunch. So no questions in the session, so please come and see the posters if you want to interact. And before starting, just an announcement. As Javier presented in the opening ceremony, we are going to have awards for best posters. So these awards will be based on your votes. So during the lunchtime and also in the poster session, there are some forms that you can use to vote for your best poster, the poster that you like most, of course, not only based on the paper, but also the interaction during the poster session. And so please vote each day right after the poster, after you attend the poster session. So now I think we can start. First paper is face likeness detection with component-dependent descriptor, and authors are Jianwei Yang, Zheng Lei, Zhenshui Liao, and Stanley. So please proceed.
Hello everyone, I'm Dong Yi, come from Chinese Academy of Sciences. This work is about face likeness detection, and the proposed method is based on the texture analysis. The aim of the work is to classify the real and fake face samples based on the difference between the texture of the face images. And the process of the proposed approach is shown in the figure. First, we crop the face image and then depart the face into several components, including eye, mouth, nose, and hair, and so on. And then we extract the LBP histogram feature from each component and weight the histogram and combine the histogram into a single histogram by the facial score. And the proposed method was innovation in three popular databases. The database is NUAA and the EDF print attack database. The proposed method outperformed the other texture-based methods significantly on these three databases. This is another paper about face likeness of ours, and but different from the previous work. This work is based on motion analysis. Compared to texture-based method, the motion-based method is more robust to the quality of the face image. The process of the proposed method is shown in the figure. We first detect 68 landmarks in each frame on the face and select several frames from the video sequence with maximum pose variations. And then we reconstruct the structure of the facial image by bound adjustment and send the 3D face shape into a SVM classifier to decide whether the face sequence is real or fake. Because the existing database usually contains face images with small variations, so we collect 3 new databases with large pose variations, and we evaluate the proposed method on these 3 databases. This method had achieved perfect performance on these 3 databases, 100%. And the advantage of this method is the method works well in various illumination conditions and various quality and works well for different types of cameras. And these 2 work was all supported by Tabula Rasa project, and we have them show in the Tabula Rasa challenge room. If you are interested in our work, please come to visit. Thank you.
Thank you. Next paper is extended click models, a new matching strategy for fingerprint recognition. So please.
This paper proposed 2 extended click models and introduced a new matching strategy for fingerprint recognition. This paper proposed a graph matching strategy. First, the local click model is proposed. Similarities of local structure can be calculated through maximum click detection. Second, the global consi-click model is proposed. The entire fingerprint similarity can be calculated through spectral techniques. In summary, this paper proposes a normal measurement for local miniature structures and proposes a graph matching strategy based on 2 extended clicks. Thank you.
Thank you. Next poster is multi-scale block local ternary patterns for fingerprint brutality detection, and authors are also from Chinese Academy of Science.
LBP operator is one of the most effective and superior methods of fake fingerprint detection, but the LBP operator has some limitations. To improve it, we proposed the multi-scale block local ternary patterns to detect fingerprint vitality. In this model, the computation is done based on average value of blocks, subregions, rather than individual pixels. The size of the block range from 1 pixel to dozens of pixels. We use the different size of LBP features and form a new characteristics to print the textual information. In order to show the differences between LB, NTP, and LBP, we showed their histogram or appearance of images. The first 3 is those of LBP, and the middle 3 is those of multiple resolution LBP. And the last 3 is the result of the MB LTP. We can see the MBP could not distinguish little finger, but the MS LBP can distinguish them. We test our method on the database of liveness detection community 2011 by the average classification error and the equal error rate. This is some of the results. For more details, you can see our poster this afternoon. Thank you.
Thank you. Next poster is human face shape analysis under spherical harmonics illumination considered self-occlusion. Yasenko Sivanov and other co-authors. Please.
Good morning, everyone. We have explored the computation of self-occlusion under omnidirectional spherical harmonics-based illumination. If you represent the illumination as spherical harmonics in a spherical harmonic spaces, then you have lights coming in from all directions. And that makes computing self-occlusion quite expensive. It's expensive in a rendering context. If you now want to invert this rendering and estimate the shape from a given image, then these costs actually become quite prohibitive, because for every point in the face you have to compute the occlusion from every direction, every spatial direction, and you have to do this multiple times. What we propose is a companion model to a morphable model of face shape, which it can be thought of as a morphable model of face irradiance, which considers self-occlusion. And with this pre-computed self-occlusion inside this model, you can simply invert the model and estimate the shape that gives rise to a certain pattern of shading just by solving a linear system of equations. We show that you can actually represent the irradiance in a linear model, and we propose a method of doing this, which is not necessarily the only way of applying our irradiance model. Thank you.
Thank you very much. Next poster is complementary countermeasure for detecting scenic face spoofing attacks by Jukka, Komulainen, and others from University of Oulu and Idia.
So, my name is Jukka Komulainen, and I'm here to present this paper about complementary countermeasures using or for detecting scenic face spoofing attacks. And this is a joint work by the University of Oulu and Research Institute, Idia Research Institute. So, Our work is based on the assumption that it's reasonable to assume that there exists no single countermeasure for detecting all known, let alone the unseen attack types. So it's important to break the problem of phase anti-spoofing into smaller sub-problems which we are able to solve using several complementary countermeasures. And it's also important to study how these countermeasures should be combined in order to build a flexible anti-spoofing framework. So in this work, we concentrate on detecting scenic phase spoofing attacks using a combination of motion and texture-based methods. And we provide an open source phase anti-spoofing framework which is available on the internet. And it's based on the free signal processing and machine learning toolbox, Bob. And it's quite easy to include new countermeasures and new fusion strategies to the framework. And it's also part of our future work. So I'm more than happy to discuss more about our work during the poster session. Thanks.
Thank you, Luca. Next poster is real-time high-performance deformable model for face detection in the wild by Junjie Jiang from Chinese Academy of Sciences.
I'm Dongyi from Kansai. And this work is to improve the speed of HOG and DPM face detector. HOG and DPM is a popular method, has been proposed mainly for object detection, and there are many existing work has applied HOG and DPM to face detection, but the speed of HOG and DPM is very slow to appear the requirement of real-time face detection. So we propose three tricks to improve the speed. First, we use a lookup table to fastly compute the HOG feature. And then we introduce a projection matrix into the framework of DPM and to reduce the dimensionality of feature, HOG feature, and to speed up, to improve the speed. And finally, we use the cascade from the cost file. The first stage of the cascade using the holistic feature, and the later stage is use the part. On the FDDB database, the proposed method has achieved state-of-the-art performance compared to other popular and state-of-the-art methods, including some commercial face detector. If you are interested in the details, please come to our poster. Thank you.
Thank you very much. Next poster is towards fingerprints as strings, secure indexing for fingerprint matching by Jess Hartloff and other co-workers.
So we're all used to the way passwords work. We can hash a password and store that in a database, and it can't be inverted. So this is one of the SHA-256 hashes of one of my passwords. I'm confident putting it up on the screen because you won't be able to invert it. We want to know how to do this with fingerprints, which leads to the bigger question of template security and biometrics, which we had a great tutorial on yesterday. We achieved this template security using the fuzzy vault construct. For the first time, we use passive minutia points as the template points for the fuzzy vault, and we extract only rotation and translation invariant information from these paths, which enables us to use a new indexing structure for the fuzzy vault, giving us a secure and scalable system. We also give a security analysis of the fuzzy vault structure concept, which is computationally based as opposed to entropy based or attack based. Thank you.
Okay, the next paper is on hard-like rectangular features for biometric recognition.
So, hello everyone. My name is Kamal from Aalborg University in Denmark. I'm pretty sure that you mostly know this kind of hard-like rectangular features that they have been used mostly for rapid object detection. They were introduced by Weil and Jones for face detection. We have used these hard-like rectangular features for biometric recognition. So the idea is to get a pool of these features and then resize them as part C in this figure in the top. Resize them to the size of the biometric image and then calculate the value of the feature, which is very much similar to the way that they are used for face detection. So if you have an image like the one in part A, so you easily use the integral image of the image to calculate the value of the feature by subtracting the value of the black region minus the value of the white region, and then take the output of all of these features and feed them to a PNN classifier. So we have used 7 public databases from 3 different biometrics on ear, hand waves, and iris images for doing the recognition, and the results are very promising. So here are the results for the eye databases. You can see that on the blue bars are the results of our system in the top figure, and the one in so the first one is for eye database, the one in the middle is for hand wave database, and the one in the below is for iris database. And then we have done an extensive experiments on different type of imaging conditions when there are different levels of noise, how the performance of the system is degraded, when there are different levels of occlusion, how the performance is degraded, and when we have different downsampling factors, how the performance is degraded of the system. And then we have also done some kind of performance on the speed, some kind of test on the speed of the system, and also the degradation of the performance when the amount of the training samples are reduced from for different levels of training sample. The degradation of the performance of the system is also illustrated. Thank you very much.
Thanks for the speaker. Okay. The next talker is on complex and movement pattern biometrics, analyzing flexation and psychology.
Hello everybody, this is my favorite mode of presentation. It has the emotional intensity of the 2-minute drill in American football. 2 years ago we presented the technique where we looked at how to identify a person based on eye movements. More specifically, we looked at the brain activity that can be inferred from such eye movement types as fixation and saccades. As a result, we have extracted approximately 15 metrics that we can employ to identify a human being. However, in our previous work, we looked at the averages of those metrics. But in the current work, we are looking at the distribution of those metrics. Also, 2 years ago, we looked at how to combine those metrics, and we just used the very simple weighted fusion techniques. However, this year we are presenting more contemporary fusion techniques. So the results of the old work are that identification rate for rank 1 was 38%, equal error rate was 28%. Rank 1 identification for the new approach is 84%, and we were able to reduce equal error rate to 17%. So as you can see, this is a very significant reduction. So what methods work best? For the statistical distribution, Kramer von Mises work the best, and for information fusion, random forest. If you would like to learn more, please see our poster in the poster session. Thank you very much.
Thank you. The next speaker is from the University of Notre Dame. His title is Automated Classification of Complex Names in Iris Images.
I'm Amanda Scry. I'm going to be presenting this work on behalf of James Doyle. So previously, cosmetic lenses have been known to present a problem for iris recognition due to the textured patterns which appear upon them. But it was also thought that soft lenses, which typically have no texture, did not present a problem to iris recognition. However, we have shown recently that people wearing soft lenses experience an increased false non-match rate relative to persons who do not wear them. So now iris recognition systems require the ability to automatically determine 3 different categories of people: those not wearing any lenses, those wearing textured cosmetic lenses, and also those wearing clear prescription lenses. To do this kind of 3-class problem classification, we propose a method that extends the previous Dogman-like method for detecting cosmetic lenses to soft lenses. This work presents the results of the first known solution to this 3-class problem. The results show that it is possible to identify with high accuracy, that of about 96.5%, to classify those images which do have textured cosmetic lenses in them. But correctly distinguishing between no lenses and soft lenses is much more challenging. So here are some rundown of the results, and if you're interested in a more detailed description, please feel free to stop by the poster this afternoon.
Thank you. The next speaker is from Osaka University. His title is Silhouette-based online signature verification using pen tip trajectory and pen holding style. Please welcome.
Yes, thank you very much. So in my studies, I would like to authenticate a person using a motion of writing signatures. And common method to authenticate the writing using writing is using pen chip trajectory. This is called online signatures. And we know online signature is a useful information for the person authentication. But in this method, we only use the pen chip trajectory. This means that we don't use any other information. So we only use this information for authentication. So in my studies, I'd like to use other information of the writing motion. So we try to use the information from the pictures. And as a feature of the writing, we focus on the pen holding style. And from the image, we extract the skin area and generate the feature associated to the pen movement and writing motion. And in my poster, I use this feature for person authentication. And I would like to show this feature is useful for person authentication. And this pen holding feature and pen chip trajectory also can be acquired using a single camera. So we fuse this method in square level fusion. And the blue line indicates the accuracy of pen holding based method, and the red line indicates the pen trajectory based method. By combining two methods, we can improve the accuracies. So I'm waiting for you in front of this poster. Thank you very much.
Thank you. The next speaker is from University of Salzburg. The title is Consumable Iris Templates Using K-Dependent Violet Transform. Let's welcome.
Hello everybody. So this is about cancelable biometrics basically, and what we introduce here is a very generic technique which is just applied here in the iris case. So you can apply it to any modality basically, but this is just as an example done here for iris templates. And the idea is to use in the feature extraction stage key-dependent wavelet transforms, where you have the key dependency plug in, and the nice thing is your template inherits most of the properties of the case without applying any key dependency. So if you have a feature extraction stage based on wavelet transforms, you just plug in these key-dependent wavelet transforms and you have very similar properties. What we did here is we examined the impact on recognition accuracy, and depending on the scheme used, we see some impact, and the other scheme we do not see any impact. So the one scheme we investigated was a wavelet filter parametrization, where basically we maintained a dyadic decomposition scheme. We just changed the properties of the filter by some well-known parametrization. The other wavelet transform is a wavelet packet transform, where we change from the dyadic decomposition to a more general decomposition structure. And it turns out that with the wavelet packet transform we can maintain the recognition accuracy, and the key dependency is also very nice, but for the filter parametrization you can see some very crazy wavelet filters up there, and you would expect, and this is also the case, there is some impact on recognition performance. So if you're interested in this stuff, please see the poster. Thank you.
The next speaker is from University of Rome 3. The title of his paper is Hill Climbing Attack, Parametric Optimization and Possible Countermeasures, an Application to Online Signature. Let's welcome.
Thank you very much and good morning. I'm Emanuele Magliorana from the University Roma III of Rome in Italy. And in the paper I will present in the poster session, we have evaluated the vulnerability of biometric recognition systems against hill climbing attacks, which basically tries to exploit the knowledge of some matching scores available to an attacker in order to generate synthetic data with which we try to break the system. Specifically, we have considered generic biometric system relying on a feature-based parametric representation and try to exploit some methods stemming from the field of function derivative-free optimization in order to define the strategies with which we define new synthetic data in order to break the system. We have also considered possible methods for providing some countermeasures against this kind of attack, which are basically based on uniform and non-uniform score quantization. From the experimental test we have performed by considering an online signature-based recognition system as a case study, we have found that the simultaneous perturbation stochastic approximation method is the one providing the best efficiency as an attack among the ones we have considered. And then the non-uniform score quantization is able to provide much more robustness with respect to standard uniform quantization when we try to provide security to the system. So if we are interested in this topic, I would like to have you and with you further discussion in the post session. Thank you very much.
Thank you. The next speaker is from Warwick University. His title is A Robust Speed Invariant Gait Recognition System for Worker and Round Identification. Let's welcome.
Okay. Hello, everyone. As you can see before, that speed is quite different for gait recognition. This definitely can give some impact on the recognition accuracy. Most of the existing work just transform all the speed into a common space before matching, but well, there are limitations. They got low performance and the sensitive to unseen speed. But we can regard this problem as an overfitting problem because for specific speed for training, that's less representative. If we realize this problem, we can generalize a generalized model to solve the overfitting problem. We just build this generalized model based on random subspace. And finally, we use majority vote among those weak classifiers. We tested on 2 data sets. We got almost nearly perfect rank 1 accuracies. Of course, we do some challenging experiments as well. We're matching walking gallery with running probe, and we found that we got more than 80 rank 1 accuracy when matching the slow runners with the walking gallery. If you have any questions, you can ask me in the post session. Thank you.
The next speaker is from University of Twente. The title is A High-Quality Finger Vascular Pattern Dataset Connected Using a Custom-Designed Capturing Device. Let's welcome.
Thank you. Vascular pattern recognition, vein recognition, if you like, is a very promising biometric with strong advantages, but unfortunately, unlike is the case with fingerprint and faces, there are very few publicly available databases and there are very few sensors. So what we did is, basically, we built a sensor, we collected a data set, we benchmarked the data set, and we made it publicly available. If you want to know the details, and if you want to know how you can obtain a free copy of the data set, you should come to my poster.
Thank you for your attention. So currently our poster spotlight session is finished, and please remember to vote the best poster presentation award. Thank you for your attention.
Now I think it's time for lunch. So okay. So at 12:30 lunch will